Hello, class. I'm here to talk about problems 26, 28, 30, and 32. And actually, I am going to leave the values. I'm going to explain them, but I'm going to leave the values here. And once I post the template, I'm not going to remove them. The reason is because I did tell you that I would not cover, I was just going to cover the goodness of fit. And it ended up that I did assign the these problems that we're going to talk right now, they are for the test of independence. Now that I actually read the problem um, and solve it, right here it tells you um, the railroad wants to know if a passenger's choice in ticket class is independent of the distance they must travel. Therefore, it is chi-square test of independence. And since the formulas, they can look pretty intimidating. And if you make one little mistake, if you refer, uh, to the wrong value once, then the whole calculation, it's gonna be incorrect. So right here, I don't expect, I'm gonna leave these values. So please go over them. Don't just type the values, please. If you only type the values, you're not gonna get credit for it. I want you to go and look at the formulas and understand what's going on. So that's why I'm gonna go over right now. You're only being provided this table right here, which is the observed value. It tells you the transit railroads is interested in the relationship between travel distance and the ticket class purchase. See, they want to know a relationship. They want to know the difference between what they observe and what they expect. So a random sample of 200 passengers is taken right here. The railroad road wants to know if a passenger's choice in ticket class is independent of the distance they must travel. Okay, so right here is what is on your book, is your observe frequency table. Remember, you need to observe and expected. The formulas you're going to be using, you can go on the summary of the chapter as I always ask you to look at it. So we're going to be looking for the test of independence right here. So maybe I can just put that over there. Let me see if I can put it over here. Okay. The test statistics is going to be the same thing as we did before. The difference is right here, you're going to be working with two different tables, and I'm going to show you how we do that. On your degrees of freedom, is it over here? Yes, it changes as well. The number of columns minus 1 times the number of rows minus 1. In this case, we could answer right away, which I put it over here. Well, you have 1, 2, 3 columns. We're testing for third class, second class, first class. So 3 minus 1. And then we have 5 rows, categories with the miles 1, 2, 3, 4, 5. So right here, if you look on the top, I did 3 minus 1, which is my columns, times the 5 minus 1 for my rows. And I got a degrees of freedom of 8. That's how we calculate degrees of freedom for test of independence. Okay, so again, the test statistic would be the same process, and I'm gonna go over right now. It just changed because we are doing um, row times columns divided by total, row times column divided by total. So let's go over here. How did I calculate the expected value right here? What I did was I did the sum of B12, B cell B12, which is the total right here. So this total right here, let's go back, times E7, which is this total over here, divided by my total right here. So I did this, the sum of this times this divided by this, and I got this value. For the second one, I did the sum of, again, this value, right? But now I'm doing this total right here divided by the same total. E8. So column E, row 8. So I'm doing this one right here. Okay, if I would put the numbers, it would take much longer. It would be way more confusing. This way, when you refer to the cells, if you change anything over here, it adjusts everything else. For example, if I change it here to 15, do you see how it changed it for you? That's the advantage of Excel. Once you learn to work with, as long as you refer to the correct cells, once you make one change, it makes a change in everything. Now I'm still over here, third class. So I'm doing the sum of B12, which is still this one. Do you notice how I put the dollar sign? That means I lock this value so the Excel doesn't adjust, just like your midterm. It doesn't update to the next value. It's always gonna do. First value is going to be 73. I did not put the dollar signs on the second one because I want to refers now to this over here, which see again E9. I want to refers to column E, row 9. So I want to refers to this total over here. So this value over here is doing this total times this total divided by the complete total, the overall total. See the dollar signs for the overall total as well, so it always refers to this on the first column. Then again, this total, now I'm multiplying by this. If you notice here, E10, column E, row 10, divided by the overall total. And then lastly, E11, so I'm doing uh, total for the third class times this total for 401 to 500 miles divided by the overall total right there. Then I complete this column. And then I summed in. Here I got the same thing. See? But now I'm noticing the difference between my I'm developing my expected table, and then I'm gonna have a third table, which is the difference of these two. Okay, so right here, now we're doing this total. And same thing, start with E7, E8, E9, and then divide it by the overall total. So, and then lastly, I'm gonna, so again, let me just do one. The sum of C12, now I'm on column C, row 12. Now I'm doing this column over here. Okay, sum of C12 times, and now I'm back to the first. So I can do 1 to 100 miles total and then the overall divided by the overall total, okay? And then you do the same thing, any change, and then you're gonna do this value times this the sum of this value times this value divided by the complete the overall total, and then this value times the sum of this value times this value divided by the overall total, and so forth and so on. And then the last column, same process, but now you're referring to this total. So now you're doing the sum of D12, column D, see right there? Row 12, dollar sign, it locks this total so it doesn't move. It only adjusts here. So E7, column E, row 7, 41. So I want to know from 100, from 1 to 100 miles for the first class and divided by my overall total. Okay, my grand total. And then next one for 42, and then which is the second category, and so forth and so on. When I finish all this, I just need to make sure the last column is giving me the totals. They should match. The total should be the same. If not, something's wrong. Because you have an observed and unexpected, however, your totals are the same, like 20 students or 200 passengers or three lottery tickets, for example. I'm just throwing some examples out there. Now that you have got all this, and like I said, you miss one of these values, everything is gone. And that's why I didn't want to go over the test of independence. And I am not going to put on your final exam. Again, I'm not going to put on your final exam. If I do, it's gonna be very simple questions, general questions about them, which you could go and refer back to the chapter. I'm not gonna put tables this large where you can miss. It's not my intention to trick anybody. As I said, I just wanna show you all the possibilities you have out there, all the calculations you could possibly do to test something. Okay, and then lastly, let's just do, now we're doing, well, right here, I already did the whole table because remember I did first the observed minus the expected. And in the other column, I did the observed minus expected square. Then I did the observed minus the expected square divided by the expected. And then lastly, I did the observed minus the expected square divided by the square. And I did the sum of them. Well, right here, this is what it's saying. The sum of the observed minus the expected is squared divided by the expected. Okay, I put the whole formula already. And actually, I didn't lock any cells because I needed to update. For example, sum of B boy 7, which is 21, minus H7 right here. See? Oh, let me go back here. Column H, row 7, which is 14.965. And the sum of that squared divided by, again, my expected, which is 14.965. And there it is. It gave me already the values because I want to know, I want to, it sums all this for me to give me my test statistic right here. So I haven't even set up my null hypothesis, my alternative hypothesis. So let's go ahead and do that. For my null hypothesis, I can say that the ticket class chosen is independent of the traveling distance. Is independent, and I can say and then the alternative, the ticket. Um, so if one is saying is um, independent, I would say the other one is dependent. So it's a test of independence. Okay, and then right here I showed you how to do the 3 columns, 5 rows. That's how we got the degrees of freedom. And now this is easier since we did all this to answer how many passengers are expected to travel between 201 to 300 miles on the second class ticket. There we go. 16.08. It's your answer, right? And then the next one now, how many passengers are expected to travel between 401 and 500, 401 and 500 miles and purchase first class tickets. There we go, 6.6. What is your test statistic? I just calculated right there, right? So you can just do equals to this value over here. You can make it less digits. You don't need all these digits. And again, we're not going to go to the table. I already used the formula over here. And I'm just going to copy over here, which is I did the chi-square distribution for a right tail. Okay, that's usually the chi-squares are all right tails. So I put Q12, Q12. So I put my test statistic and then for 8 degrees of freedom. Okay, so I'm gonna repeat it here. So it's gonna be equals to my chi. See, you just have to type the first letters and then you choose which one, and it's telling you what is X, which is your test statistic. Okay, comma, what is your degrees of freedom right here? And then they should match. There we go. Just make less digits. Here you go. That's your p-value. Therefore, now you can make your decision. Uh, did they give you? No, they did not give you an alpha on this problem, or they did down here, right? Oh, I'm sorry, right here. So if your alpha is 0.05 and your p-value is 0.0435, well, your alpha is actually greater, right, than your p-value, correct? So if your alpha is greater than your p-value, then it's gonna be that your conclusion, or what is your decision, we reject the null hypothesis, and we can say that there is sufficient evidence. We didn't prove, there's just sufficient evidence to conclude that the selection of tickets, or the selection of ticket class, is dependent on travel distance. And that would be done for problems 26, 28, 30, and 32. Again, I am gonna replace or post the template with this, and I'm gonna leave the values in there. I need you to take a look, and if you do use if you do copy the values, don't copy the values. I'm going to be looking for the formulas. Either I'm going to be looking for the formulas, or I'm going to be looking for that you actually use the values to make the calculations. If I go over here and I notice there is nothing, you just type the numbers as they are. No points are going to be given for the problem. Okay? And as usual, let me know if there are any questions. And we are now done with problems with chapters 9, 10, and 11 in 1 week. It is possible. And next week, we are going to have the whole week for linear regression. And on Friday, I'm going to be releasing your final exam. And then chapter 13 will be covered the basics on the last week, week 8. And then don't forget your research paper is also done at the end of the term. And with all the we have covered so far 11 chapters, then next week 12, so you should have more than sufficient enough information to answer in your questions for your research paper and provide a good analysis. So as usual, let me know if there are any questions, and I hope all these videos have helped this week.